Hi guys, what's up? I'm Dinesh. Welcome you all to another lecture of the chapter Matrix and Determinant. In this video, we are going to see about some special types of matrix. So here I am going to discuss about the symmetric and skew symmetric matrix. So let's get into the lecture. Okay, for symmetric matrix, a matrix is said to be symmetric if A transpose is equal to A. If A transpose is equal to A. So in terms of elements, matrix is symmetric if Aji equals to Aij. This is important. Aji equals to Aij. So let's take j equals to 2, I equals to 1. So what does mean? A21 equals to A12. In this order, you can put any j and any I. If you get these relations, then only the matrix is symmetric. So let's get into an example. A matrix A is given. It's a symmetric matrix, but how to prove? Here you see A is 1, 3, 5, 3, 2, 8, 5, 8, 3. Obviously a 3 cross 3 matrix. So for symmetric, what you have to do? Just find A transpose. So A transpose, you know already. I have already made video on transpose of a matrix and its properties. So how to find the transpose? Just interchange the rows into columns. So R1 write as C1, you will get 1, 3, 5. R2 write as C2, you will get 3, 2, 8. And R3 write as C3, you will get 5, 8, 3, which is nothing but the transpose of the matrix. Okay. So you see, you verify A transpose is equal to A. Look at the first row 1, 3, 5 and 1, 3, 5. Second row 3, 2, 8, 3, 2, 8. And third row 5, 8, 3, 5, 8, 3. Or in terms of elements, you also can verify. Just put any element A 2, 3. So A2, 3 is A2, 3. Second row, third column is nothing but 8. So verify A32. A32 is also 8 equals to A32. So you can verify by taking transpose of that matrix and equating all the elements are equal, or by taking any random elements of the matrix to verify the symmetric nature of the matrix. So in this way you can verify, you can show the symmetric matrix. Okay. So the important points you have to remember: for a symmetric matrix, you required n square plus n by 2 number of elements. This number is important. N square plus n divided by 2 number of elements to write the matrix. So n is nothing but order of matrix. It may be second order or third order or fourth order or fifth order and so on. Okay. So why I write this? Let's prove it. So what you have to do? For any matrix A, I say n cross n, you can say number of element. How many number of elements? Number of element, obviously n square. Simply n cross n square number of element. For symmetric matrix, you know, there is n diagonal element, yes or no? N number of diagonal element. Okay. So and total number of element n square. Okay. So non-diagonal element. So number of non-diagonal element is nothing but total element minus diagonal element, yes or no? Okay. So you have already seen here Aji equals to Aij. Simply it means half, except the diagonal elements, all other elements are equal. So if you forget about these diagonal elements, these non-diagonal elements are equal 3, 5, 8 as the condition Aj equals to Aij. If you know Aj for a symmetric matrix, you obviously find Aij and inversely. Okay, means if you know Aj, you also get Ai elements. So number of elements required to find a symmetric matrix is nothing but, so you can say minimum number of element requires to write symmetric matrix, so it's nothing but n squared minus n by 2 plus the diagonal element n. This is very simple. This is n square minus n non-diagonal elements divided by 2 plus n. If you solve this, you will get n square minus n plus 2n divided by 2, which is nothing but n square plus n by 2. I have already mentioned in the line. This point is important. So if you have a 10 cross 10 matrix, so and it's a, so question is, if you have a 10 cross 10 matrix, so minimum number of elements required to write the symmetric matrix, and given it is symmetric obviously. So and question is number of elements required to write this 10 cross 10 matrix. You can find here n equals to 10. So number of elements required is nothing but n square plus n by 2, which is nothing but n square is 100 plus 10 by 2, which is 55. So 55 number of elements required to write a 10 cross 10 symmetric matrix. Okay, in this way you can solve problem. So let's move into skew symmetric matrix. So what a skew symmetric matrix is? So for a skew symmetric matrix, if for a matrix A, if A transpose is equal to minus A, for symmetric it was A transpose is equal to A, for skew symmetric it is A transpose is equal to minus A. And look at the terms of element condition. So if Aj equals to minus Aij, then it is skew symmetric. But very interesting, if when I equals to j, you get Aii is equal to minus Aii, which is not possible, so that these elements must be 0, so that you can say Aii or Ajj must be equals to 0. So I have written here, so diagonal elements of skew symmetric matrix are 0. Okay, so you have to remember what the diagonal elements of a skew symmetric matrix are 0. In example here you see, you will get A transpose is equal to minus A, but here the diagonal elements are non-zero, so it's not a skew symmetric matrix. Important to say. So example of skew symmetric matrix is this, because you first verify the diagonal elements, you see all the diagonal elements are 0, then verify its transpose, you will get 0, minus 1, minus 2, just write the columns into rows, 1, 0, minus 3, 2, 3, 0, and take minus common, you will get simply 0, 1, 2, minus 1, 0, 3, and minus 2. Just write the negative as positive and positive as negative, and 0. You will come back with the same matrix A. So here you verify A transpose is equal to minus A. So it's a skew symmetric matrix. In the very next lecture, we will see some very important properties of symmetric and skew symmetric matrix, and I will solve one problem to make you more understand about these concepts. Okay, I hope it's helpful for you. Please like and share the video, and never forget to subscribe the channel. Thank you so much.